Hi, I'm Patrick.
And I'm Dereck.
And together, we're here to talk to you about ways you can take your 2D Android apps to the next level in XR with 3D content. For those of you who aren't already familiar, Android XR is the newest platform in the Android family. It's built for extended reality devices like headsets and glasses. The first Android XR device will be a headset, Project Muhan from Samsung. Starting from its launch later this year, the ecosystem will expand further across headsets and glasses. In today's session, we'll cover some of the 3D capabilities introduced in the developer preview of the Jetpack XR SDK, and some practical ways you can use them to make the content in your app really stand out on XR devices. To do this, we'll use a 2D app for learning about animals as an example. Throughout this talk, we'll add 3D capabilities to the app to help that tiger and the other animals come to life. This will take advantage of the XR environment and create a more immersive, engaging user experience than what's possible in 2D. We've made the new Android XR emulator available as a part of the developer preview, so you can try out the features we'll cover today for yourself. One of the great things about Android XR is that it works hard to support apps with little or no changes. By default, apps that don't make changes for XR will run in a mode called home space. Home space is the first thing users see when they put on a headset. It's kind of like free-form desktop windows for your Android app, but on a seemingly infinite virtual display. Android apps without XR affordances open in a single panel in home space. One of the major benefits of home space is that it enables side-by-side multitasking with other apps. Home space is great, but it's just a 2D surface for your app inside a 3D space. To access the full capabilities of the 3D space, you need to access a different mode, called full space. Full space is the setting where your app has full access to the immersive capabilities of Android XR, including 3D content. When an app enters full space, other apps are hidden, and the app comes into focus, taking up the full view around you. To help your app transition between home space and full space, we provide APIs that can switch back and forth at runtime. To learn more, check out our guide on transitioning from home space to full space on developer.android.com, or see how this is implemented in the Hello Android XR sample app. So now that you know about both home space and full space, it might be tempting to only support full space for the most immersive experience your app can provide in Android XR. But it's important to give your users the best possible experience for your app in both modes. This is because your users will often want to multitask while using your app, and they'll need your app to run in home space to do that. Optimizing for home space is largely the same as preparing your app for tablets and other large screen devices. We have another talk on this at Google I/O, so please check out Adaptive Android Development. Makes your app shine across devices. Once your app is in full space mode, you can start using the SceneCore APIs in the Jetpack XR SDK to take advantage of the spatial capabilities of Android XR. This includes the ability to create the right setting for the user, whether that's keeping users grounded in the real world with pass-through, or a virtual environment. Maybe your app wants to transport users to a landscape far in the past or future. Or maybe you want to provide a calming environment where your users can focus on your app's content. Virtual environments can take your users there. In our example app for learning about animals, we think it'd be cool to transport our users to a peaceful wilderness environment that matches our theme. To do that, we need to understand some core concepts: skybox and geometry. You can think of a skybox as a distant image, like a photosphere that surrounds your users. This creates the illusion of a distant background, such as the sky, mountains, or a cityscape. Your skybox can contain image-based lighting information to determine the way Android XR should light the 3D content around your user. Geometry, on the other hand, adds shape and depth to your user's environment, creating real parallax effects for a more realistic sense of immersion. Geometry is typically used to show the ground the user is standing on and objects near the user. Once you're familiar with the concepts, you'll need the right files for your environment, and you'll need to ensure that they're optimized to be used on Android XR. You can learn more about environment assets and how to optimize them in our documentation on the link on the screen. Once you have the right files, you can load them in your app and use them to set the spatial environment. Once that's done, our users are immersed in our peaceful wilderness environment. If you want to return the user to the real world around them, you can do so by setting the pass-through opacity preference. Setting the environment around the user is great, but let's look at some other ways to immerse your users. Video can be an effective way to engage users in your app on other form factors, and Android XR introduces new ways to take your video experience to the next level. You can wrap video around the front of your user with a 180-degree video, or completely surround your user in a sphere with a 360-degree video. Whether your video is on a sphere, a flat surface, or something in between, you can introduce real depth to your video by using stereoscopic content. Stereoscopic content provides a 3D effect by showing slightly different images to each eye. In each eye's image, the closer an object is to the viewer, the more it's offset, mimicking natural depth perception. The two images are normally stored in the same frame, either above and below each other or side by side, like you can see here. Both approaches are often referred to as side-by-side formatted video, but we're also including support for the MVHEVC video format as well. Beyond delighting your users, immersive video can serve practical purposes, like giving your users a tour of a new physical space in a way that's intuitive to navigate by looking around. All of this from the safety and comfort of their own home. The APIs that allow you to create objects in 3D space are provided by the SceneCore library, and every element you create is called an entity in SceneCore. The entity we're interested in for showing the user's immersive video is called Surface Entity. As its name suggests, it creates a surface that we can render video to. While it's tempting to have a stereoscopic video of a tiger leaping towards our users, let's look at how we can use this surface entity to wrap a 360 video of a relaxing nature preserve around our users instead. To work with entities, and a lot of the other capabilities of SceneCore, we'll use the XR Session class. The session is the primary interface for apps to access SceneCore functionality, so you'll be seeing a lot more of it today. To create the surface entity, we'll need to pass our instance of the session into the factory method, and we'll specify the format of the video as well as the shape of the canvas. We specify mono because this video is monoscopic, meaning it presents the same video to both eyes, lacking depth information. We also specify that we'll need a sphere for our canvas, since it's a 360-degree video. We're also passing a head pose into the method to position the sphere correctly where the user is looking, and Dereck will share a bit more about that in a moment. After the surface entity is created, we can use familiar Media 3 APIs, like ExoPlayer, to play the media by setting the surface entity as the surface for your player. Once the video is playing, our users can look around as the video wraps around them regardless of whether they're immersed in a virtual environment or their real-world surroundings with pass-through enabled. Pretty cool, right?
Dereck here with some fundamental concepts for working in 3D space. When you build for Android XR, you're quite literally adding a whole new dimension to your app, so I want to make sure that you have the tools you need to build with confidence. Earlier, we passed a head pose to the surface entity when we created it. Poses are used to position entities in 3D space. A pose represents the position and orientation of an entity in 3D space, and it contains two pieces of information: a translation and a rotation. To break this down, the translation part is a 3D vector that allows us to specify how far in the X, Y, and Z dimensions we should move the entity to get it in the right position. When we have the entity moved to the right point in space, we use a quaternion to specify how it should be rotating such that it's facing the correct direction. You can copy a rotation from one pose to another to have objects face the same way. In situations where you want to apply a unique rotation to an entity, you probably want to create the quaternion from the Euler angle values, because those are a lot easier to reason about. Euler angles describe the rotation of an object along the three axes, colored red, green, and blue in this example. Then, we can create a quaternion to use it in a pose, using from Euler angles. Another important concept is parent-child relationships. Just like in 2D layouts where items can have children that are positioned relative to their parents in a view tree, entities can have children in a 3D scene. The position and rotation we just talked about are always relative to the parents of the entity. Entities can also have components attached to them. Components are used to add behaviors to entities. Movable component adds simple controls that allow users to move the entity. Resizable component adds grabbable corners that allow users to resize the entity. There's also interactable component, which lets you capture raw input events performed on the entity. In this example, we use an interactable component and capture the action down event to make a tiger roar. Wait, to make a tiger roar? It's time to talk about showing your users one of the most engaging capabilities available in Android XR, displaying 3D objects. In our example app, we want to show the user a close-up look at a tiger. Let's take a look at how we can make that happen. Before we get started, we'll need an asset for the 3D model. For Android XR, we'll want to use a GLTF file. GLTF support many of the features that you would expect to see from a modern 3D file format, including physically based rendering materials that can make your models look real and add animations to bring your models to life. The simplest way to show a GLTF to your users is by using our intent-based 3D model viewer, Scene Viewer XR. This launches the system viewer and our app steps back to let the 3D model take center stage. When you want the user to see the 3D model at the same time of the rest of your app's UI, you can load a GLTF resource directly in your app. This gives you more control over things like position of the 3D model, the relative size, or fine-grained animations. To load a 3D model in our app, first we'll create the model from the GLTF. We'll use a GLB file, which is the binary transmission format for GLTFs. It's optimized for smaller file sizes and quicker loading times. Once we have the model loaded, we'll use that model to create an entity, and it will be displayed to our users and lit by their environment. We can position this entity with a pose, and by setting its parent the same way we discussed before. It looks a little static right now. Let's bring it to life. When the model is being displayed to our users, we can play one of the animations contained in the model by specifying its name, and whether we'd like the animation to loop or not. Right now, some of you may be wondering, where should I get GLTFs to use in my app? There are a variety of tools available to create and animate GLTFs, my personal favorite being Blender. Our tiger animation was pretty fun, but there's a lot more you can do with 3D objects in your app. Maybe your users want to see what a sofa your company offers would look like in their living room. Or maybe you'd like to transport your users to Paris to see the Eiffel Tower up close. To learn more, check out our documentation on adding 3D models to your app. If you're familiar with ARCore on mobile devices, you'll be happy to know that we're bringing familiar concepts to Android XR as well. ARCore for Jetpack XR helps your app understand the real world around the user, making use of perception capabilities. One of my favorite features from that library is persistent anchors. To break that down, anchors ensure that objects appear to stay at the same position and orientation in space, helping you maintain the illusion of virtual objects placed in the real world. Persistent anchors is a feature that remembers the location of a given anchor in persistent storage. To show you how this works, we'll add one more feature in our example app to allow users to hang up portraits of their favorite animals in XR. First, we create an anchor. In this case, we use the pose that our painting entity is currently at. Then, we persist the anchor. This saves the pose in local storage and gives you a unique identifier that can be used to retrieve that same location later. Use the identifier to load an anchor, like so. The anchor has a pose located at the same space in the physical world that it was at when it was persisted. Android XR doesn't just give us new ways to show our users things. ARCore for Jetpack XR introduces capabilities that unlock new ways for your users to interact with your app, letting you use the user's hands to create delightful experiences. The primary mode of interaction on Android XR is with your hands. To obtain detailed hand tracking and pose information, you'll need to ask for the user's permission first, using the standard Android permissions model. Hands are represented by a collection of 26 joint poses. You can use these poses to create a variety of interactions using hands. In this example, we calculate whether or not the index finger is outstretched by checking whether the index proximal is pointing in the same direction as the index tip. We can combine these calculations to detect a stop gesture. In this gesture, it's important that all the fingers are outstretched. In our example app, we use this to freeze the tiger's animation in its tracks. We're actively adding new AR features and fixing bugs with the XR emulator, so be sure to check out the release notes to see the latest progress and file bugs or feature requests in the issue tracker.
We just walked you through some of the most powerful 3D capabilities ever available on Android, with real examples. This only scratches the surface of everything that's happening right now for Android XR. We've already added support for the new KHR animation pointer specification, and we're in the process of adding support for the upcoming KHR interactivity specification as it's emerging. Open standards like the GLTF specification and its extensions are always evolving, so we recommend following the Kronos group for the latest information on standards, watch for more announcements regarding support on Android XR, and look out for which digital content creation tools are the first to implement specific extensions. For apps built with Unity, we've introduced the Android XR SDK for Unity. This SDK builds on Unity's long-standing support for XR development tools like AR Foundation, OpenXR, and the XR Interaction Toolkit, bringing them together with the platform-specific features tailored for Android XR. With each release, Unity continues to expand what's possible on Android XR, adding new capabilities, improving performance, and enhancing stability across the stack. Developers can take advantage of features like URP application space warp and eye-gazed foveated rendering to deliver high-quality visuals with better performance. Plus, XR templates and a dedicated Android XR build target to get started faster. Check out the Android XR blog post to learn more. To help you get started, we're continuously updating our documentation, sample code, and the APIs themselves, as well as our tools. We've added new 3D capabilities to our Hello Android XR sample app, and we've just recently added XR differentiated features to the Jetstream sample app as well. We've also published a 2-part code lab to help you get started developing for Android XR. And last but not least, whenever possible, we recommend that you position your UI and create panels in Android XR by using Jetpack Compose for XR. Be sure to check out our other session, The Future is Now, with Compose and AI on Android XR to learn more. This is all a part of our developer preview, and we genuinely want to hear from you about what you love, what you wish was better, and what else we should provide to help you create immersive, engaging experiences for your users. Keep the links to the issue tracker components handy and get started today. The developer community is one of my favorite things about Android. Dereck and I can't wait to see what you build in XR.